Hi, this is Vanitha, Math Facilitator from Confusion to Clarity. In the last video, we have discussed about the types of relations. Today, we'll solve some examples related to the same topic. We start with example 1. Find the number of reflexive relations on the set containing element A and B. We consider the given set with elements A and B. Here, number of elements in the set is 2. We know the formula, number of reflexive relations is equal to 2 power n square minus n. Now we substitute n is equal to 2. So 2 power 2 square is 4, 4 minus 2. So then 2 power 2 that is equal to 4. Therefore, the number of reflexive relation on the given set is 4. Now we move on to example 2. Find the number of symmetric relations on the set containing the elements 1, 2. Now we consider the set 1 and 2. Here the number of elements is 2. Now we know number of symmetric relations is equal to 2 power n square plus n divided by 2. We substitute n is equal to 2 here. So 2 power 2 square is 4. 4 plus 2 divided by 2. 4 plus 2, 6. 6 divided by 2 is 3. So 2 power 3 is 8. Now the number of symmetric relations on the given set is 8. Move on to example 3. The maximum number of equivalence relations on the set A which contains element 1, 2, 3. Now I'll tell you the trick. Now we start with number 1. We copy the same number 1 here. Now you add these two numbers. 1 plus 1 is 2. You copy this 2 here. Now you have to add these two numbers. 2 plus 1 3. Add these two numbers and write here 5. Then copy this number 5. Add the number with the above number. 5 plus 2 7. 7 plus 3 10. 10 plus 5 15. What is this? Here, n is equal to 1. It means that number of elements in the set is 1. The maximum number of equivalence relation on the set is 1. When the number of elements in the set is 2, the maximum number of equivalence relation on the set is 2. When the number of elements is 3, the maximum number of equivalence relation on the set is 5. When the number of elements is 4, the maximum number of equivalence relation on the set is 15. Now you see the question. How many elements are there? There are 3 elements. When n is equal to 3, the maximum number of equivalence relation on the set is 5. The correct option is 5. Now we move on to example 4. Let A is equal to collection of elements 1, 2, 3 and R is equal to collection of all order pairs 1, 2, 2, 3, 1, 3 be a relation on A. Then R is. Let's find the correct option. First, I consider the set A which contains 3 elements and we consider the relation set R which contains 3 order pair. First, we check reflexive. The definition is every element of the given set must be related to itself. It means that 1, 1, 2, 2, 3, 3 must be in R set. But we do not have all the 3 order parts here. So this not belongs to R. So we say that R is not reflexive. Now we move on to symmetric. Here we choose any one order pair from the relation set first. We just reverse it 2, 1. We check whether 2, 1 belongs to the relation set. No. So, but 2, 1 does not belongs to R. Therefore, we say R is not symmetric. Now, we move on to transitive. For transitive, we take 2 order pairs from the relation set. One order pair is 1, 2. Since it is ended with 2, we take the order pair which starts with 2. Now we have to check the third order pair 1, 3 belongs to R or not. Yes, it belongs to R. Now we move on to the second order pair 2, 3. This order pair ended with 3. There is no order pair starting with 3. We leave it. Now we move on to the last order pair 1, 3 ended with 3. Started with 3. There is no order pair. So we conclude R is transitive. Here we have got R is not reflexive, R is not symmetric, R is transitive. Which is the correct option? Yes, option C, transitive. Now we solve example 5. Relation R contains elements 1, 1, 2, 2, 3, 3 on the set which contains element 1, 2, 3 is, we find the correct option. Now we consider the set A with elements 1, 2 and 3 and the relation R which contains an order pairs 1, 1, 2, 2, 3, 3. First we check reflexive. We have to check whether every element of the set A is related to itself or not. It means that 1, 1, it means 1 is related to 1, 2, 2, 2 related to 2, 3, 3, 3 related to 3. Whether these elements exist in the relation set or not. Yes. So I can conclude that R is reflexive. Now we move on to symmetric. To prove symmetry, we have to choose any one order pair first from the relation set. Now, you have to reverse it. When we reverse also, we will be getting the same element. Belongs to R. Similarly, 2, 2, 3, 3 belongs to R. When we reverse it, we will be getting the same order pair. Now, every element of this relation set satisfies the condition. That is, for every x, y belongs to R implies y, x belongs to R. So, I could conclude that R is symmetric. Now, we move on to transitive. For transitive, we have to choose two order pairs from the relation set. First, I take the first element. To choose the second order pair, the condition is the second order pair should start with this element. But we do not have any such order pair. There is no order pair starting with 1. And when I take 2, 2, here it is ended with 2. There is no order pair starting with 2. 3, 3, here it is ended with 3. There is no order pair starting with 3. Now we will get a doubt whether it is transitive or not. Yes, still it is transitive. Therefore, I could conclude that R is transitive. Now here we see R is reflexive, symmetric and transitive. Any relation which satisfies all the three conditions, we call it as equivalence relation. So here R is an equivalence relation. Which is the correct option? Option C. Hope you all understand. Catch you in the next session with different topic. Thank you.